I'm Brian DeLuca, and I am here with Cameron Lowe, and we're at the Tektronix booth at APEC 2025. Cameron, can you show us what's new?
Sure. What we have showing at this particular demo station is our double pulse test solution. So double pulse testing, of course, is meant to characterize the switching behaviors of devices in the silicon carbide or gallium nitride type of topologies. And what we're looking at, this is a silicon carbide based module. And the setup that we have here is we have a couple of different probes that are used to capture the signals for double pulse testing. So we have a differential probe used for capturing high side VDS. We've got one of our newer isolated current shunt probes that is looking at the drain to source current. And we've also got a different differential probe looking at the VGS signal.
Okay. So what are one of the things engineers need to know about these new scopes?
So I think the most important part is scopes nowadays have much better hardware that is more accurate, more visible, better resolution, higher bandwidth, but it also makes use of a lot more software that can do real-time analysis. So for instance, the 5 series scope that we have sitting here makes it so that you can do energy on, time to turn on, a lot of the most advanced power, double pulse testing measurements in a real-time application, and it can be more automated, more repeatable in terms of its measurement setup and capture.
Now, is there anything else you want to show us over here?
Yeah, I think a couple more pieces. We just recently acquired a company called Elektro-Automatik into the tech portfolio, and this provides us the capability to provide a higher power density and high power supplies for double pulse testing. We're also using one of our function generators. This is the AFG 31000, and this is a really great tool for simplifying the ability to set up and stimulate your double pulses onto the gate drive.
So now, can you talk a little bit about how this works? Because you said this is specifically for SiC and GaN, right?
Yes.
So can you talk a little bit about what the difference is between that and other scopes, why this one is different?
Yeah, so traditional scopes, of course, can capture double pulses, right? 2 different pulses of varying pulse widths. What's unique about our particular setup is a couple of things. One, the isolated current shunt probe has a really high common mode rejection ratio associated with it. So it's able to filter out a lot of the common noise interference that gets presented in high switching environments from silicon carbide and gallium nitride. The scope itself has measurements that are specifically tailored for double pulse testing. So the wizard that you walk through within the measurement says that you feed in some of the base parameters, you connect it up to the function generator over there through a network connection, and then all I have to do is hit go on the gate stimulus, and it'll control the function generator over there, set up 2 different pulses, and then capture those 2 and make real-time energy on, energy off loss measurements on the oscilloscope.
That's very nice. Thank you for sharing with us.
Thanks for coming by.
Appreciate it.